Well, hello and welcome to one more session in our journey in understanding Java. So, we will be continuing our operator session, and in this operator session, we are going to learn how to use the logical operators, the shift operators, and the shorthand assignment operators. So, without any further delay, let's jump right in. So now let us quickly discuss what are logical operators. There are three types of logical operators in Java. One is the double ampersand or the AND operator. One is the double pipe sign or the OR operator. Or the last one is the exclamation sign or the negation operator or the NOT operator. So the first example that we see here in this class, logical operators, is that of the AND operator, which is represented using double ampersand sign. So AND operator operates on Boolean literals or Boolean expressions. So both the LHS as well as the RHS of the operator has to be evaluated to a Boolean value if it is an expression, or we can directly provide a Boolean literal as we have done in this case. So if both the values, that is the LHS and the RHS, are true, then the output of the operation will be a true as well. In all other cases, it will be false. So if it's a true or a false, it will be false. If it's a false and a true, it will be still a false. And if both the sides are false, of course, it would be false. Now moving on to the OR operator, which is represented using two piped signs. Here, only one of the LHS or RHS, if it's a true, then the output will also be a true. So if both sides are true, the output will be true. If one of the sides is just true, the output will still be true. In this case as well, we can see that the RHS is a true, so the output is a true. And if both the sides are false, then the output will be a false. So that's all for logical operators. We'll now discuss what are shorthand assignment operators next. So now we will be discussing what are shorthand assignment operators. So if you can recall that we have already covered arithmetic operators as a part of our previous session. So basically, this introduces a new shorthand way of writing arithmetical expressions. So each of the operators that we have under arithmetic operators has a shorthand notation to do the same operation. So in this example, we'll quickly go over how to do those. So first of all, let's say there are two operands, operand A and operand B, and we want to add them. So let's say the expression is operand B equals to operand A plus operand B. So instead of writing that entire thing, what we can only write is operand B plus equal to operand A, and that's it. So what is the shorthand assignment operator? Shorthand assignment operator is this plus and equal to. So whatever operation that we want to perform, that we need to represent, as well as it should be along with the assignment operator. That's why the name is shorthand assignment operator. If you come to the next example of subtraction, so let's say you want to subtract operand B from operand A, you can do the same in this way as well using the minus equal to operator. So in this case, if we expand this expression, it is similar to operand A equals to operand A minus operand B. If we go to the next example, if you want to multiply this operand A with operand B, what we need to do is operand A into equal to, this is the multiplying sign, into equal to operand B. So basically, if we again expand this, it is similar to operand A equals to operand A into operand B. Same way we can divide as well, and same way we can modulo as well. So that's all there is for shorthand assignment operators. Next we are going to cover shift operators. So now we will be understanding how to use shift operators. So let's quickly go over this code snippet that we have here and try to understand it better. So first of all, we will see what is a left shift operation. So let's take a integer 1, which is represented in 32 bits in this particular fashion. So we see the most significant bit towards the right is only set to 1. All other bits are set to 0. So this representation is that of a integer 1. So now, since this is a positive integer, it is quite straightforward. So what we have to do is we have to left shift the bits. So all the bits present in this entire representation will be shifted towards the left. But by how many positions? So that is how we specify while we are shifting the number itself. So this is how we write it. So first of all, the number that we want to shift, we write it in this way. Then we use the left shift operator, which is using the left chevron character. And then we specify how many places to shift towards the left. So we have specified 3. So we can see that all the bits in this 32-bit representations will be shifted 3 places towards the left. So the one which we see here has now moved to the 4th position. And same goes for all the zeros. So the new value of this representation is integer 8. So if we left shift 1 3 times, the output will be 8. Now, similarly, there is a right shift operator as well. So again, let's take, for example, one more integer 128, and its 32-bit representation will be in this manner. So we see all the leading bits are 0. And in this 4th segment, we see there is only 1 and rest of it is 0. So if you convert this 32-bit representation to decimal, it will give you 128. Now I want to shift all these bits present in this number few positions towards the right. So how do we specify that? So this is how we write it. So we write the number in which we want to shift the bits. Then we use the right shift operator, which is right chevron size, and the number of positions that we want to shift the bits by. So in this case, it is 2. So I want to shift all the bits that we see in this number 2 positions to the right. So basically I see the one which was set here, it has gone 2 positions to the right and sits at this position. Now if you convert this entire number into its decimal representation, it will be integer 32. Now to introduce just a bit complexity in this operation, I thought of introducing you to how we use the right shift operation on a negative number. So right shift has 2 variants. So one right shift operation is called signed right shift and another operation is called unsigned right shift. So what is the difference between the two? So let's take the help of these 2 next examples to understand this use case better. So let's take minus 16. So since minus 16 is an integer, but it's a negative integer, so how do we represent it in memory? So first of all, we write down the positive 16's value. So this is the 32-bit representation of positive 16. Now we do a 2's complement of this positive 16 and arrive at this value. So that is how we represent negative 16 now. Now when we want to do the shift operation, it has to happen on the 2's complement representation of negative 16. So now I want to do the signed right shift operation on this number. Now what that basically means is your leftmost significant bits, when they are being shifted towards the right, whatever is the value, it will be retained. So in case of a negative number, we know the least significant bit is always a 1. So whenever we are shifting that value, that bit, that last bit towards the left to the next place on the right, what will be the value of that last bit now? It will be replaced by a 1 because it is still retaining that 1 for the negative representation of the number. So that is what signed right shift operation does. So whenever you are shifting bits from the left to the right, if the number is negative, that means the leftmost significant bit contains a 1, that value is preserved and gets passed on to the bits towards the right. So in this case, what we see is when we are shifting this entire number towards the right, we see this one goes towards the right by 2 places, but here towards the left, we still see 2 1s take up the 2 empty bit positions because the value was preserved. The signed bit which was set there, it preserved its value. Now, if we take same negative number 16 and do a right shift of it in unsigned manner. So we are going to use the unsigned right shift version to change the value of negative 16. So how do we write the unsigned right shift operator? Unsigned right shift operator is written using 3 chevron signs. So whenever you're writing this, it means that you don't want to preserve the sign of the leftmost significant bit, even though if it is of a negative number. So again, taking the example of negative 16. So negative 16, how are we going to represent in internally in memory? We are going to first make it a positive 16, write it down in binary, which is this, and then do a 2's complement. 2's complement representation becomes this, and then on this we are going to do the unsigned right shift operation. So we are going to shift all the bits which are present here 2 places to the right. So if we do that, we can see that this one goes to this place now because it shifted 2 places to the right. Now what is going to happen towards the leftmost significant bit? So towards the left, it was set to a 1, but since these 2 bits were shifted to 2 places towards the right, we see it is not preserving the value of the original negative number now. It is getting replaced by a 0. So that is the biggest difference between how we do the signed and the unsigned right shift operation. So after this unsigned right shift operation, the value of this entire binary number will be this number in decimal. So that is how left shift and right shift operator works. And we have just seen how we can use the unsigned right shift and the signed right shift on a negative number and observe the difference between the both. So friends, hope you had a great time with this video and grasped the concepts of Java operators. Next, we will be covering if-else, switch statements, for, while, and do-while loops, and also understand how to use break and continue while using loops. So a lot of goodness ahead, and hope you all are excited as I am. Also friends, if you haven't already liked and subscribed, please do so. It motivates me a lot to make such content. Until next time, bye.